doing single replacement reactions, what we're going to do is we're going to have a single element out here off to the side, and then we're going to have a compound. And what's going to happen is you're going to end up taking part of that element and subbing it in for another part over here. So if you think of this water as HOH, okay, it's going to sub in the lithium for that hydrogen, and it kicks the hydrogen off on the other side by itself. So here the hydrogen sits by itself. Do you see that? And then you're forming lithium hydroxide. Again, be very careful with your oxidation numbers. This is a +1, this is a -1. People will want to bring over and drag over stuff, or they'll forget to like make this into a Brinkelhoff. So be careful with that. All right. What you have to do when you do these is you have to look and see if the element's more reactive than another element. Okay. And what I normally do for this is I tell folks, okay, so you're going to kind of think of this as a roster. Okay. So if we had like a football team, okay, and we had this as our roster, Aaron Rodgers, he's the quarterback for the Packers, right? And then we have, I don't know, who's the quarterback for the Badgers? QB Badgers, whoever that is. Okay, and then we had our high school quarterback, whoever that is. I don't remember who the quarterback is here. And then we had Lippy, right? Me. Yeah, me playing football. Not pretty, okay? Can't throw, not coordinated at all. So if I'm in the game, right, and Aaron Rodgers comes by, what are they going to do? They're going to kick me to the bench and put him in the game, right? But if Aaron Rodgers is in the game and I'm sitting the bench, are they going to put me in? No, not a chance, okay? And that's the way this activity series works. And this activity series is on your, in your, orange sheet, okay? So for example here, and then the halogens run in order that they appear on your periodic table. So fluorine, chlorine, bromine, iodine. All right. Here, fluorine has arrived. Bromine is in the game. It's in a compound here. Fluorine is going to bump bromine off to the bench. Bromine's going to be sitting by itself, and fluorine's going to come into the game. But if the opposite were true, if now we have fluorine in the game, this is like Aaron Rodgers, okay? They're not going to put Lippy in the game if Aaron Rodgers is around, okay? So there's no reaction, there's no change, nothing would happen. Silver, if we find silver on our list, silver is down here, copper is above it. So if copper's in the game, if it's in the compound, silver's not going to come in and replace it. Does that make sense? And if you look at this activity series, what's interesting is that you can see the things that they consider precious metals end up at the bottom down here. And you're like, but they don't react. And that is why they are precious. Okay? They're precious because they stay pure. All right? When I go and wash my dishes and there's some, you know, the lead or the, not lead, but the iron, cast iron pan, I don't have to worry about taking my gold ring off because the iron's going to replace that gold. It's non-reactive. So I don't have to take my rings off. If I had instead an aluminum ring though, I needed to be very concerned because that aluminum ring would not last. Okay? So let's look at some examples of these. We also have single replacement reactions that occur here, so that end up being no reaction. And if you look at your orange sheet, I have this as a call-out box off to the side. We have some situations where certain metals are more reactive than others. Okay, so here we've got aluminum. Aluminum's more reactive than lead. Lead's going to sit the bench. Aluminum comes into the game. Here, magnesium is on the bench. Silver's in the game. Magnesium drops silver over here. If you've ever seen in the grocery stores, there's like Tarnex. Essentially what Tarnex is it will take that magnesium and set it in there and keep your silver pure. So if you've ever had to like polish silver, you guys probably have it because most people don't have like silver. Their silverware is really stainless steel now. And then here, it's not going to be a reaction. Again, we have some special situations where these metals interact with water. So we have sodium interacting with water. That's going to form sodium hydroxide and hydrogen gas. And this is on that orange sheet, that call-out box off to the side. So you have all of your stuff here, and then there's a special call-out box up here. Do you see that on your orange sheet? Do you have an orange sheet? Okay, these are your alkali, and almost all of your alkaline earth metals are going to fall into this category. It's going to form a hydroxide. The active metals then are going to form, oops, these slides must be out of order. The less active metals form an oxide and hydrogen gas. And these are listed out here for you. So you just have to check this list. So when you see a single element, a metal and water, you have to go to that little call-out box and figure out what's going to happen. And then these lesser active metals do not react with water. That's why if you live in a house that was built in the 60s or 70s, you probably have copper pipes down in your basement, not PVC. Because the copper is not supposed to react with the water. Okay, that's why back in the day we had lead pipes. Okay, and they took those out. So there's some issues with that. But these will not react with water at all. So there's no reaction. And then you've got some acid situations here where you would just produce hydrogen gas. Okay. So let's try a few of these. We have calcium and we have iron oxide. All right, again, just write the equations out like you normally have. And then we're going to go back and we're going to check that activity series. So we need to find calcium on here. And we need to find, what was the other? Sorry. Here we go. Calcium and iron. Calcium and iron. So calcium's here and iron is here. So calcium is more reactive than iron. So calcium and iron's down here. So iron is in the game right now. This is like Lippy being in the game. Okay, because they're further down on the roster. Good? So what's going to happen? That calcium's going to come in and it's going to bump that iron by itself. It's going to make it sit on the bench and calcium's going to come into the game. Does that make sense? All right, we've got francium and water. So francium is what? Where is it at on your periodic table? Francium's in the first column. What's that first column called? Do you guys remember the name of those metals in the first column on your periodic table? That first column is called your alkali metals. So again, this is a metal with water. So that's where you're going to go to that special call-out box. So if you have an alkali metal and water coming together, what does it make? Look in that call-out box. It's the first one listed there. What does an alkali metal and water make? On your orange sheet, look on in the call-out box off to the side.
Hydrogen?
It makes hydrogen. What else does it make?
Metal.
Okay, what's your metal here? It's francium, so it's going to make francium hydroxide and hydrogen gas. And then you need to get this balanced. So I'm going to put a 2 here, and then I'm going to put a 2 here, and a 2 here. And now I've got it balanced. I'm going to take lead, and I'm going to put that with water. So in your call-out box on your orange sheet, see if you can find lead on there and tell me what that makes.
This is not reactive.
Right, so you just do NR, no reaction. Done.
How would you balance it?
There's no reaction, you don't balance it. You just move on to the next problem. Nothing happened. They're not going to interact. They're not going to make anything. So you don't have anything to balance with it. The next one is lead oxide and gold. So now we've got a metal and it's trying to replace another metal here. So this is where we're going to look at that activity series. So find aluminum on there and find gold. Which one's higher up on the roster? Aluminum, okay. So, I'm sorry, this was lead, not aluminum. I don't know why I said that. So lead is above gold though, right? Yeah, okay. So if lead's already in the game, this is Aaron Rodgers is already in the game, are they going to sub in Lippy? No. Why would you put me in when that man is in charge? There's no way he's better than me. So if lead is higher up on the list, on our roster, right, it's not, gold is not going to go back in there and replace it. So this is another no reaction. All right, then we have aluminum and water. So this is water with a single element. We're going to look to that box again. Can you find aluminum in that box? Okay, what does it say to do?
Reacts with steam to form metal oxide and release hydrogen.
Okay, so form metal oxide. What's my metal over here? Aluminum. So I'm going to make aluminum oxide. I need to look at my oxidation numbers. This is a +3. This is a -2. So I need to get that to balance. And then it also makes hydrogen gas. Okay, then I've got to balance my equation. So I need a 3 here. I need a 2 here.
Wait, why do you need the 3 there?
Because I've got 3 oxygen on this side.
Oh, I didn't see the O after. Sorry, I saw the H2. Okay.
So I'm going to put a 3 here. That's going to give me 6 hydrogens. So I need to put a 3 there to get up to my 6 hydrogens. All right. So this is copper fluoride, CuF2 plus bromine. And we want to try to figure out what's going on here. Now, this isn't written on your orange sheet. You follow your periodic table. That's your roster, so to speak. Okay? So on your periodic table, is fluorine above bromine? in your halogens. Yes. So if fluorine's above and fluorine's already in the compound, is bromine going to bump it out? No, because this is like Lippy. This is like Aaron Rodgers. If Aaron Rodgers is in the game, they're not going to put me in. Okay? So this is another no reaction. All right, next slide. See if you can do some of these on your own. Ask me questions. Stop me and talk to me about stuff. So iron's in the game. Lithium wants to sub in. Are we going to sub lithium in?
What are you supposed to do with the 2?
The iron 2, that just tells you that when you write the formula, it's going to be Fe2. Oh, sorry. Shouldn't have done that. FeO. This is a +2. This is a -2. So it's already balanced.
So you don't, or why don't you put the 2 though?
Because oxygen is a -2. So there, it balances the charges out already without doing anything. That tells you, Carly, what this number is right here. Because iron has different options for the oxidation number, so it's telling us what number to put here. Then we look at our roster. Is lithium higher up on the roster than iron? So what's going to happen?
Where are you looking to see if it's higher up?
This is your roster here on your orange sheet.
Okay, yes.
You got your roster here. That's your roster. So if lithium is higher up on the roster than the iron, then it's going to go in the game. And since lithium's the star player, it's the Aaron Rodgers of metals, it's going in the game. And iron's going to end up sitting on the bench. Okay? Don't forget, don't look over here for your oxidation numbers. When you get over to this side, reevaluate them. This is a +1, this is a -2. So I've got to have 2 lithium for every 1 oxygen. Yep. All right, this is with water. It's a single element with water. So where do we go on our orange sheet? What section are we going to go on our orange sheet for this one? Got a metal and you got water. Where are you going to go? Go to that call out box, right? Which category is this going to be? Is it going to be the first, the second, or the third thing in that call out box? This is the call out box. You're over here on this little box right here.
I don't see it. Does that mean it's in?
Well, where is this found on the periodic table? Where is cesium at?
Oh, so it'd be.
Huh?
Should be active metal.
Very active metal. This is an alkali metal.
Right.
So alkali metals do what?
They react with water or steam to form metal hydroxide.
Okay, so what's my metal?
Yeah.
So what am I going to form?
So.
It said hydroxide though, right? Hydroxide is OH. So it's going to form CSOH plus hydrogen gas. and we balance the equation. Good. How about this one? What is this going to form? Manganese and water. Can you find that? This is an element and water. Where do we go for elements and water? Where do we look? Yep, the little side box right here. So can you find manganese and water over here? What does manganese and water form? Metal oxide and releases hydrogen. Okay. Next one is lead oxide and calcium. All right, now we've got to go and we've got to look at our roster here. Yeah.
So I just have a question. You put like O's after, like for the one before this one, you put like an O after manganese or whatever.
Yeah.
And then the one before you put OH. Like what's different about those? Because they were like the same.
This is hydroxide and this is oxide. And it tells me in my rules, look at the call out box. It tells me for alkali metals that forms a metal hydroxide.
But was the second one the same thing?
No, manganese is not. You're thinking of magnesium. Manganese is Mn.
Oh, okay. I was thinking that they were the same, and I was wondering why it was different. Okay.
Okay. So this one is an active metal, but it's not a very active metal. And then here, we need to look at our roster. Is lead more reactive than calcium? Or is calcium more reactive than lead? Which one is a better player, so to speak? Calcium. So calcium is going to bump lead off by itself, and calcium is going to come into the game. All right, the next one is mercury and water. Mercury's coming into the game with water. It's a single element and water. So when we have a single element and water, where do we go? Little side box. Can you find mercury in the little side box? What does it say? Non-reactive. So we write NR and we move on. All right. The next one is copper and iodine. It's reacting with fluorine. Where do we look for our roster for these? These aren't on here. Where do we go to try to find out which one of these is better? Periodic table. Very good. Okay. Find fluorine and iodine. Which one is the better player? Which one's higher up on the roster? Fluorine is higher up. Fluorine. Then we have chlorine. We have bromine. And we have iodine. Iodine's in the game now. Is fluorine a better player than iodine? It's higher up on the roster, right? It's the Aaron Rodgers of halogens. Okay. So fluorine is going to go into the game, and iodine is going to go and end up sitting on the bench.
So how did you find that it's higher up? Because I don't even see fluorine.
Go to the periodic table.
Oh.
Your halogens are listed on the periodic table.
Okay.
Right?
Yeah.
All right. Questions on single replacement reactions? Anything not make sense on that before I move on to combustion? All right. So combustion reactions take place in the presence of oxygen. So oxygen is one of the elements that's present in a combustion reaction. Okay? There's several different options here. When we ask you reaction types, if you told us synthesis here, we'd be fine. If you told us combustion, we would be fine. They are both. You can say either one. All right. Complete combustion of a hydrocarbon is here. Okay. When a complete combustion of a hydrocarbon happens, we form CO2 and water. This is below, right below your single replacement reactions. It's a little box right here. Do you see that? Hello, Harley. There you go. Okay. Notice that I've marked out on yours incomplete. Okay. And the reason why I did that is I want you to know that this happens. And I want you to know that as kind of a public service announcement. But when you do the equations, this is what you're going to be working with because it's going to make balancing a lot easier. But I want you to know that it forms, normally, it's most of the time it is incomplete, and it's going to form CO2 gas. CO2 gas is colorless and odorless. You don't know it's there. That's why a lot of people have carbon monoxide alarms in their homes because you start to feel very sleepy, you fall asleep, you die. Okay? This happens in your furnaces all the time. If you have a gas dryer, this happens in your dryer all the time. You have a vent to the outside world. It vents that CO2 out. But sometimes those vents get clogged. And that's why you need a carbon monoxide detector to make sure that you don't die. Okay? Because it's colorless, it's odorless. You don't know it's there. You have no ability to pick it up. And what it makes you do is it replaces the oxygen. Your hemoglobin prefers CO. It prefers carbon monoxide. But your body can't get rid of that off of your hemoglobin. So you take this in and you have a really hard time of getting it gone. Your blood picks this up and it doesn't pick up any oxygen. And after a while, you fall asleep because you don't have enough oxygen and then you die. Okay? Every year in our area, we'll have a few deaths that are caused by carbon monoxide poisoning. Okay? So I want you to know that this happens, but when we do equations in here, this is what we're going to be working with. Okay? But I still keep this on because I like to talk about it so you guys are aware of it. All right. Lithium and oxygen. Li and O. 2. Oxygen is a Brinkelhoff. I bring those together. I form lithium oxide. Okay? And then I need to balance that. So lithium, I need 2 of those over here. Oxygen, I need 2. Even and odd, double the odds. So I'm going to put a 2 here. Which takes my oxygen up, but it messes up my lithium. So if I put a 4 there, I get that imbalance. Good? All right. Now, I'm going to give you, these are hydrocarbons. Okay? So I'm going to give you a list here of what to do when you have a hydrocarbon combustion reaction. So how to balance a hydrocarbon combustion reaction. RXN is the abbreviation for reaction. Number 1, look at the carbon. If it is odd, go to step 3. If carbon is even, go to step 2. Put a 2 in front of the hydrocarbon. Number 3, balance carbon. 4, balance hydrogen. 5, balance oxygen. So those are the steps for balancing a hydrocarbon reaction. Write them down. Memorize them. Make it work. Because if on 9-3 you struggled to get number 10 to balance, this would have made that a breeze. And then the last step is just check to make sure that your coefficients are at the lowest ratio. If you doubled that carbon, you might need to go back and reduce these down. This works. This putting a 2 in front of this works about 95% of the time. Occasionally, like I said, you'll end up with a situation where you need to reduce because it's not at the lowest ratio. But I would say about 95 to 99% of the time, these rules work. Okay, so I'm going to go up here. I'm going to do one of these. Oops, I don't like that one.
When you're done with this, can you go back? Like after you're done.
Yeah, I can go back. There you go.
Sorry.
That's okay. I just sigh a lot, especially with these face masks on. I don't know. It's hard for me to catch my breath some days.
I mean, I understand that, like, they're supposed to help and everything, but, like, I do get sick of wearing them, like, really easily.
I sigh a lot normally, even without face mask.
Okay, thank you.
Yep. Okay. So again, when we have a hydrocarbon and oxygen, we are going to form CO2 and H2O. So step 1, I look to see if this is an even amount. It is not. It is odd. So I'm going to skip to step 3. Step 3 tells me to go and balance my carbon. Step 4 tells me to go and balance my hydrogen. Step 5 tells me to balance my oxygens. 5 times 2 is 10 plus 12. I end up with 22. So then I go over here and I balance my oxygens. I put an 11 here and I've got it to balance. Make sense? All right. Then I want to do one with an even number. Oops. Okay. We're going to go back up here. I'm going to change this one to an even number so you can experience that. So let's make this 8. Okay, I don't even know if that thing exists, so I'm just making it up. C8H20 plus O2. Always the same stuff, CO2, H2O. Step 1, are my carbons an odd or even amount? This is an even. If it's an even amount, put a 2 here. Then I go and balance my carbons. 2 times 8 is 16. I balance my hydrogens. This is 20. I know it doesn't look like it, but it is. So I'm going to put a 20 there. So now I'm going to go and balance my oxygens. I have 20 from here. 16 times 2 is 32. So 2, that's 52. Half of 52 is 26, and now I've got it to balance. See how we do that? Everybody good with that? That makes sense? Okay. All right. So tonight you have 9-5 to work on. And I want to see that on Wednesday when you get back in here, okay? So 9-5, and then you'll have another assignment tomorrow, which you'll need to tune in for, okay?